Hello, this is Mahanaim. Today I will present my presentation titled A Comparative Data Analysis of Mortgage Loan Approval Rate Predictions in case of Mississippi and South Dakota. This project is part of Data 670 Data Analytics Capstone course. I am excited to share my findings and the methods I used to explore racial disparities in mortgage loan approvals across these two states. I'll take you through the project's journey in today's presentation, starting with the background and problem description to the predictive model developed, and finally discuss the key insights and actionable recommendations. Homeownership is a cornerstone of wealth accumulation in the United States. Mortgage loans play a critical role in this process, enabling individuals to purchase homes through financial institutions. However, significant disparities exist in mortgage loan approval rates between racial groups, particularly between Black and white Americans. For instance, as of 2022, the homeownership rate was 74.6% for white Americans, but only 45.3% for Black Americans. This disparity is fueled by factors like income inequality, historical redlining, and limited credit access. My project investigates these disparities using mortgage approval data from Mississippi and South Dakota to identify patterns and biases in the lending process. Existing research highlights that racial minorities face disproportionately higher denial rates for mortgage loans. Studies using Home Mortgage Disclosure Act data have revealed biases in loan approvals, even when controlling for income and credit scores. The 2018 expansion of HMD data introduced richer variables like loan pricing and credit scores, offering deeper insights. Research also shows that minority borrowers tend to pay higher interest rates and fees. However, gaps remain in the analysis of state-specific disparities, especially in demographically distinct states like Mississippi and South Dakota. My project addresses these gaps by focusing on these two states to uncover racial disparities at a regional level. The primary problem addressed by this project is the racial and socioeconomic disparities in mortgage loan approvals. The analysis centers on how race, income, and other factors influence approval outcomes. For example, Black applicants often experience lower approval rates than white applicants even when they have similar financial qualifications. These disparities directly impact wealth accumulation opportunities for racial groups. My project explores these issues using data from Mississippi and South Dakota, leveraging demographic diversity to understand patterns and potential biases. The ultimate objective is to identify these biases and support fairer lending practices. The scope of this analysis includes investigating racial disparities in mortgage approval in Mississippi and South Dakota. These states were chosen due to their distinct demographic characteristics, enabling a comparative analysis. The focus is limited to race-based disparities, excluding gender, to provide a targeted perspective. Data sources include HMD and US Census demographic data for both states. Predictive modeling techniques are applied to assess how race and socioeconomic factors affect approval outcomes. This comprehensive approach combines statistical and machine learning methods to uncover disparities and provide actionable insights. The goal of this project is to provide clear insights into how racial demographics influence mortgage approvals across different socioeconomic contexts. It aims to identify systemic biases in the lending process that contribute to racial disparities in home ownership. By analyzing the data, the project seeks to offer policy recommendations to promote equitable access to mortgages. These recommendations will be grounded in data-driven findings, ensuring they address the underlying issues effectively. Ultimately, this project aspires to bridge the racial wealth gap by contributing to fairer lending practices and improving opportunities for home ownership. The dataset for this project comes from the 2023 HMD loan data for Mississippi and South Dakota. It includes over 122,000 records, with 97,878 from Mississippi and 24,138 from South Dakota. covering 99 attributes initially. These attributes include loan amount, interest rate, property value, and the binary target variable action taken, indicating the loan approval or denial. Additional demographic data from the 2020 US Census provides socioeconomic context such as racial composition and income distributions in applicant communities. Missing values were handled systematically to ensure data completeness, especially for critical attributes like census tract and race. Redundant attributes were removed to streamline the dataset, preserving only the most relevant factors for analyzing approval disparities. Outliers in financial variables such as loan amount were transformed to prevent the model's predictive accuracy from being skewed. After cleaning and pre-processing, 82,278 rows and 38 columns were retained for model development. This project's success was measured using specific key performance indicators. The models were expected to achieve a minimum accuracy of 84% and precision level above 80%. Additional metrics like F1 score and area under curve were used to evaluate predictive power, targeting AUC value between 0.8 and 0.9. Bias reduction in predictions was a critical KPI, focusing on minimizing racial disparities in loan approval outcomes. Data completeness and quality were also prioritized throughout the data cleaning and model processing. This visualization reveals disparities in income and loan amounts by race and state. White applicants in Mississippi shows the highest income levels and receive the largest loan amounts. Conversely, black applicants have significantly lower incomes and loan amounts. In South Dakota, overall economic activity and loan distribution are lower compared to Mississippi. These findings highlight systemic economic disparities that directly impact loan allocations. The visualization underscores the importance of addressing racial and geographic disparities in mortgage lending. When we come to this focuses on loan application outcomes, specifically approval and denial rates by race and state. White applicants in both Mississippi and South Dakota show significantly higher approvals rate compared to black applicants. Mississippi exhibits a pronounced disparity in application volume with far more approval for white applicants. In contrast, South Dakota has fewer applications overall but maintains similar disparities in approval rates. Black applicants face disproportionately higher denial rates, especially in Mississippi, where systemic biases may be more entrenched. This trend underscores the impact of racial disparities on loan application outcomes, aligning with the broader theme of the project. The next visualization examines the relationship between loan types and reason for denials. It shows that black applicants are more likely to receive high-cost loans, indicating challenges with affordability and financial barriers. Mississippi has greater proportion of high-cost loans compared to South Dakota, highlighting geographic differences in lending practices. Denial reasons such as credit history and debt-to-income ratio disproportionately affect black applicants, suggesting structural challenges in creditworthiness evaluations. Interestingly, a significant proportion of denial occur in early stage and are labeled as not applicable, potentially indicating procedural barriers. This insights highlights systemic issues in loan accessibility, particularly for minority groups. This visualization shows on mortgage types and denial reasons, emphasizing racial and geographic disparities. Black applicants have a higher representation in high-cost mortgages compared to white applicants, underscoring affordability challenges. When broken down by states, Mississippi shows a slightly higher prevalence of high-cost mortgages than South Dakota. Denial reasons also vary by region. Credit history and income ratios are more critical factors in Mississippi, while collateral issues dominate in South Dakota. These findings illustrate the combined effects of race and geography on mortgage accessibility, revealing structural challenges in lending practices. Addressing these disparities requires targeted policy and practice interventions. The predictive modeling process involved 4 models: ensemble logistic regression with bagging, ensemble decision tree with bagging, random forest, and gradient boosting. Each model was trained on cleaned and pre-processed data with partitions optimized for validation. Skewness in the data was addressed using log and square root transformations, and outliers were managed using the interquartile range methods. This slide presents an overview of the dataset features and exploratory data analysis. The dataset contains input variables such as income, interest rate, debit to income ratio, loan amount, and loan term, which predict the target variable action taken, a binary outcome, approved or denial. The input features are categorized as nominal in interval, indicating the data type and role in the analysis. The visualization on the right summarizes the feature distribution, revealing trends and patterns such as skewness. These insights inform feature engineering and model design, ensuring the most relevant variables are used for accurate predictions. Justification for model selection. Ensemble logistic regression with bagging is chosen for its straightforward interpretation, making it suitable for analyzing the direct effect of race and income on loan approval. Ensemble bagging method improves robustness by averaging results for multiple decision trees, which helps reduce overfitting and increase reliability. Random forest leverages bootstrapping and majority voting to improve prediction accuracy, especially in identifying complex relationships in approval decisions. Gradient boosting is chosen for its ability to uncover subtle data relationships, build strong sequential learners to capture complex patterns, and offer flexibility for various datasets. This slide presents the modeling process and results for evaluating different machine learning algorithms. The workflow includes data preparation steps like filtering, imputing, variable transformation, and partitioning data into training and validation sets. Multiple models were tested, including ensemble bagging with logistic regression, decision tree, HP forest, and gradient boosting. Each model was evaluated on metrics like accuracy, sensitivity, precision, F1 score, and ROC. This part presents the performance comparison of 4 predictive models developed for this project. The ensemble bagging decision tree outperformed all other models, achieving the highest accuracy of 99% and the best sensitivity, capturing 99% of true positives. Random forest and gradient boosting were followed closely with an accuracy of 98%, demonstrating strong predictive power as well. All models displayed high precision values, maintaining a range between 98% and 99%, which minimized false positive rates. The F1 scores were consistently strong, with the decision tree achieving the highest score of 0.99, indicating an excellent balance between precision and recall. Additionally, the decision tree, random forest, and gradient boosting models all achieve a perfect ROC value of 1, underscoring their ability to distinguish between positive and negative classes effectively. The ensemble bagging decision tree emerged as the champion model in this study. It achieved a 99% accuracy rate on both training and validation datasets, demonstrating exceptional predictive power. The model excelled in sensitivity, identifying 99% of true positives, and achieved a balanced precision and recall with an F1 score of 0.99. Its robustness was enhanced by bagging, which reduced variance and improved stability. This model provided the most reliable insights into patterns and disparities in loan approvals. This slide highlights the achievement of key performance indicators defined for this project. All models surpassed the targeted accuracy of 84%, with the champion model achieving 99% accuracy. Precision level exceeds 80%, meeting the expectations for reducing false positives. The F1 score also reached 0.99, ensuring a balance between precision and recall. The AUC metric achieved a perfect score of 1, reflecting the strong predictive power of the models. These results validate the reliability of models and their ability to provide actionable insights into loan approval disparities. The analysis highlights stark racial and geographic disparities in mortgage lending. For instance, income disparities and systemic biases disproportionately affect minority groups, particularly in Mississippi. Recommendations include introducing equitable lending policies, state-specific interventions, and enhancing lenders' training to mitigate biases. In conclusion, the analysis highlights significant racial and geographic disparities in mortgage loan approvals. Mississippi, with its larger black population, showed distinct patterns in approvals, reflecting potential inequities in lending practices. South Dakota provided a contrasting perspective, enabling a comparative understanding of regional trends. The ensemble bagging decision tree effectively identified the factors affecting loan approvals, offering a data-driven foundation for policy recommendations. The findings emphasizes the need for equitable lending policies and the role of predictive analytics in addressing financial disparities. The key recommendations to reduce disparities in mortgage loan approval emphasizes addressing socioeconomic inequalities, particularly in states like Mississippi with significant racial disparities. Policymakers should advance income inequality, improve credit access, and remove systemic barriers to promote fair lending. Financial institutions can enhance fairness by using advanced predictive models like ensemble bagging decision tree to mitigate biases. Broader datasets and additional variables such as credit scores and income should inform future research for a deeper understanding of lending disparities. Nationwide application of these methods is feasible. Training loan officers in data analytics and regularly reassessing lending practices are critical to ensure fairness and inclusivity in the mortgage industry. Now I would like to provide feedback on Nguyen's presentations titled Dementia Risk Prediction in Patients Based on Behavioral, Lifestyle, and Demographic Factors. The project's interdisciplinary approach is one of the strongest aspects as it integrates behavioral, lifestyle, and demographic factors to offer a holistic view of dementia risk. This comprehensive perspective enhances the relevance of the findings and provides deeper insights into the interplay of these factors, which is crucial for designing effective prevention strategies and interventions. The project's objectives are clearly defined and the data sources are thoughtfully selected to uncover meaningful trends and correlations. Additionally, the goal of enabling early dementia detection through targeted screening tools highlights this research's potential public health impact. The strengths of TRI's presentation are that the innovative approach of focusing on non-medical features such as behavior, demographics, and lifestyle provides a unique perspective on dementia risk prediction. The model performance is noteworthy with the random forest achieving AUC of 0.873 and a sensitivity of 0.836, demonstrating its effectiveness. Additionally, TRI identified significant predictors like depression, hypertension, and smoking, which are valuable for developing targeted interventions. Lastly, the proposed solution is high scalable, offering a cost-effective alternative for early detection in public health settings. TRI's presentation, while strong overall, does highlight a few gaps that could be addressed. This includes the limited sample size and reliance on synthetic datasets, which may affect the study's generalizability. Some models also face challenges with low precision and imbalanced class distributions. Additionally, there are few direct correlations identified with positive dementia diagnosis. To enhance the work, I would recommend collecting larger or more diverse datasets, incorporating additional demographic factors such as economic level, education, and location, and refining features engineering to improve predictive accuracy and better address these gaps. Overall, TRI's work is both insightful and impactful. Thank you for your attention. I hope this presentation have provided valuable insight into the systemic challenges in mortgage lending and how data analytics can help them address.